Let's think of a pattern that we'd like to build. Maybe we want to go back to making the left to right color change black to red, but we want the dot size to get bigger as we move down the image. This is another great use for a nested loop. Why? Because we want to change two things, and in this case we probably don't want to change them in the same way. What's the largest point size we can have and still see separate points on the screen? Let's write some test code. Wow, that got big fast. Obviously, we need much smaller point sizes than that. Let's change it. Okay, it looks like we can get away with a stroke weight of 10 and still see the dots. So the range of our dot size is going to be from 1 to 10. How are we going to construct these loops? We still want our dots to get more red as we move from small values of x to large values, but as well, we want our dots to get bigger as they move down the screen, increasing values of y. Let's look carefully at those three statements in the middle. The first is a mathematical expression to limit the largest possible value of the stroke weight to 10. But it's based on the current y value and the maximum y value, the height. So that says as y gets larger, the dots get larger, but adjusted for the dot size as we wanted. The next line says make the dots redder as the x gets bigger. The final line uses the two variables that are being updated in the separate loops to actually draw the dots. Looking at the image, some of you will be wondering if all the sizes are changing the same way. Yes, they are. What you're seeing is an optical illusion where your eyes are making the image look less even than it is. If you look closely at any individual section, you'll see the dots are the right size. It's just when you try to look at the whole image that your eyes get confused. You don't have to put all the code statements inside the nested loop, and we can show you what happens by moving some of them outside. This is also going to show you how the values change. If you look at the stroke x00 statement, you'll realize it only changes when x does. So there's actually no need for it to be inside the while loop. So we can do this. And the result is identical, except that we aren't carrying out a whole lot of unnecessary stroke changes. What about the other two statements? Well, they depend upon the value of y, which is changing inside the loop, so they need to stay in there to do what we want. But what if they move? For reasons that will become clearer later on, I'm going to make a change to the code to allow me to move some code around. What do you think will happen when this code runs? Well, we get this result. Wow. We seem to have one column of tiny dots on the far left and then everything else is the largest value. What happened? Well, what happened here helps you to understand how loop updates work in a nested loop. On the first pass through the x loop, y has the value 0, and this sets the tiny stroke weight. But then we hit the while loop, and that while loop is going to keep iterating until y hits its maximum value. Then it will stop, and then we get to the end of the x loop, do the update, and go back up to check the condition. But the y value is still set to the value that caused the old y condition to stop. When we have nested loops, the loop inside must finish before we pass control back to the outside loop. Now let's go and practice some of this.